Hello guys, we're here for video 2, elements, compounds, and mixtures, and we're looking at them at the submicroscopic level. We have introduced these ideas at the macroscopic level in class, and now we're going to start to get into the submicroscopic just a little bit. So first thing we need to remember is about elements, and each of these ideas, elements, compounds, mixtures, homogeneous, heterogeneous, make sure that you look up in your textbook in the back glossary or that you look online and find where you can define these words, that you have a clear understanding of definition and then match the picture to the definition. So first, let's start with elements. Elements generally can be found in two forms. Now, we all recognize these are the simplest form of matter, and that typically these are when we look at these samples submicroscopically, they are all the same element. So we have this one here that's just single atoms. That's in the gas form. It could be gas, it could be liquid, it could be solid. Here also we have a diatomic element. Oxygen, nitrogen, hydrogen is a all of those are diatomic elements. Some other examples are bromine and chlorine, iodine, fluorine, and those are some pretty standard elements that we'll be dealing with later in the year. But what's important to know is that they run around in pairs, because elements are any time you have the same atom, the exact same atom. And we're indicating the same atom because they are all the same color. But remember, elements in the real world don't actually have color, not submicroscopically. Compounds, on the other hand, are usually two different elements physically bound. Go back and look at the last image of the diatomic element and see how that's different from this compound. Just notice that they're physically touching, the green and the yellow, and that's the way that we're indicating a chemical change that has bound these two together. Compounds can exist in a variety of phases. One of the ones that trips students up the most is the solid phase. Sometimes when students see the solid phase, they think that it's not, they think it's two separate elements, or they think it's some sort of mixture. But this is often how we find compounds in the solid form. Those atoms are physically touching each other and they alternate. They're very organized, very rigid in shape. Now let's start to get into the mixtures. So we know that there's two different types of mixtures, homogeneous and heterogeneous. For the record, I say homogeneous. You can also say homogeneous and heterogeneous. That's a little bit weirder for me, but hey, to each his own. So with homogeneous mixtures, they typically have one phase throughout. By one phase, uniform, that's one form throughout. So an example of one mixture here is two elements. Notice that those two are not physically touching. Go back and rewind and look at that compound and compare that to this one. Here's another one that's an example of one element and one compound together. Hopefully autofocus will work soon and you'll be able to see that a little bit more clearly. Keep in mind that there's an unlimited number of possibilities. This one, you have a gas and you have a liquid, but you could have almost anything. These are uniformly mixed throughout. That doesn't mean that they're perfect and rigid and organized. It just means if I take a couple of different samples, I get a roughly the same mix. Next, we have heterogeneous mixtures. So heterogeneous mixtures have two different phases within the same container. Those two different phases can actually be two different ones, like in this case, gas and liquid, or two liquids or two solids. A good example is this green and blue one here. In this case, the gas is floating over the top and the liquid is at the bottom. This is not considered uniform because if I were to sample the top of the container, I would get generally just green. And if I were to sample the bottom, I would generally get just that diatomic blue one that is there. Another example, and imagine that you're looking at, say, oil and water right at the surface where they touch. So oil and water in the same container. Right at the surface where they touch, there are actually two liquids. Even though both of them are liquids, they're two different liquids that do not mix uniformly. And because they don't mix, quote unquote, together uniformly, they are actually considered two different phases. So we put them in the container together. So technically we mix them together, but because their atoms do not uniformly mix, they're considered two different phases, hence heterogeneous. Here's another one that's very interesting for students to sometimes see. This is a solid one. Sometimes the solid ones are a little weird, where you have two different elements sitting side by side. they could potentially be physically touching, but the point is that the yellow ones are not kind of evenly mixed in with the green in some sort of organized pattern. We have all the yellow on one side and all the green on the other. That's an example of a heterogeneous mixture. Imagine that we were looking at a chocolate chip cookie right at the surface where the chip touches the rest of the cookie. We might have one side that's, say, the chip, and one side of that interface being the cookie. So I guess that's about it. Make sure that you add to your foldable your definitions of heterogeneous mixture, homogeneous mixture, compounds, and elements. Those are some very important words to know. Also, molecule and atom are also very good words to know. Thank you so much, and see you in class.